Elephant Racing has a kit to replace the rubber bushings on the front control arms of the early Porsche 911 series. There's another product on the market, we'll call it Brand X, which also provides a replacement rubber bushings. But there is a significant difference between the products. The first thing that you notice is that the Elephant Racing kit comes with a set of OEM spec bushings and a set of proprietary tools to facilitate the installation. That's because it's impossible to install an OEM spec bushing without specialized tools. Brand X took a different approach. Their kit does not include tools. So to facilitate a toolless installation, they altered the design of the bushing itself. And we wondered what those changes to the bushing design would do to the performance of the bushing. So we put together a series of tests to compare them and see how they stack up.
Let's have a look at the physical difference between the two products. On first glance, they look similar. On closer look, we find that Brand X has a much larger inside diameter. There's a 3 millimeter difference between inside diameter of the Elephant Racing bushing and Brand X, yet the outside diameters are the same. That means that Elephant Racing is compressed much more tightly, is squeezing much more rubber between the arm and the mount than Brand X. Brand X has a looser fit.
An important property of a rubber bushing is that it holds the control arm concentric in its mount. That means minimal deflection under load. Deflection is bad because it causes toe and camber changes to happen dynamically, which makes the car a handful to drive. The second aspect is permanent deformation, what's often called cold flow, or the property of the rubber to take a set. The design of the front suspension on the 911 places a torsion bar at the center of the control arm, and a bushing that becomes sufficiently non-concentric allows that control arm to rub against the torsion bar, grind a groove in it, and ruin it. That's an expensive proposition because both the torsion bars and the rubber bushings then need to be replaced. A second important property of the bushings is how they accommodate rotation. By design, the OEM bushings accommodated rotation by stretching. They do not slip against the control arm or the mounts. Slippage causes rapid wear of the bushings. A bushing that accommodates rotation through stretch, on the other hand, will last a very long time, as did the OEM bushings. The second aspect of that is that a bushing that stretches will always try to return to the same neutral position, corresponding to the static ride height of the car. On the other hand, a slipping bushing has a constantly shifting neutral position, causing a constantly changing corner weight on the car. These are the two properties that we have devised the test to evaluate. So let's see how the bushings perform.
So here's our test rig, and what we're doing is we're using an arbor press to apply force onto the control arm, and we can measure the amount of force by a load cell with a digital readout. This is actually a computer corner balance scale pad, and then we measure displacement with a dial indicator. Now, this is the Elephant Racing OEM spec bushing. You can see that it is perfectly concentric. The dial indicator is set on 0, showing our reference point, and there is a black indicator here on the dial indicator which will not move, which will show us where that 0 point was for easy reference. So let's go ahead and start to put some weight on it. Let's go ahead and turn it up to 1,200 pounds, and this would reflect 2 1/4 times the static weight, and you've overshot a bit, and that would be a worst case load. There we are. We've exceeded 1,200 pounds. We're looking at 25 thousandths of deflection total. Let's go ahead and release that. Let's do another cycle. See what happens. Take it up to 1,200 pounds. You're well over 1,200 pounds. Okay. Well, even at that, we're at about 24. I think we might have peaked at 25, but we overshot our weight. All right, let's go ahead and release it. And again, we're back to about 2.5. Okay. And we can see clearly that we're starting the test, and the bushing, you can see, is perfectly concentric in the mount. And the dial indicator, let me raise this. The dial indicator is on the 0. Okay, let's go ahead and turn it up to be 1,200 pounds, which would reflect a maximum loading that we would expect to see. There's 1,100 pounds. All right, there we're just about 1,200. Okay, already we're not even quite to our target load. There's 1,200. And let's see, we've already seen 65 thousandths of deflection, and it's continuing to creep upwards. There's 30. So yeah, we've reached 70 thousandths of deflection. Okay, now let's release that and let it cycle back to 0. There's 0 pounds, and we see that the needle is not returning back to its original 0 point. That would suggest that the bushing has deformed already from a single cycle, and the deformation looks like about 45 thousandths of an inch. All right, let's do another cycle up to 1,200 pounds and see what happens. So what we've seen already is that the bushing's become deformed. It seems to be starting to stabilize at around 87 thousandths or so. It goes a little more. Yeah. Okay, well, we can ease off it. So it looks like around 87 thousandths is where it stabilized. On the 0, let's see where the 0 point stabilizes at. So we're looking at somewhere in excess of 60 thousandths. The 0 has drifted just from, we've done now 6 cycles. And that's it. So we've seen 60 thousandths of deformation of the bushing. Cold flow, if you want to call it that. Pretty dramatic. Let's see how concentric that bushing remains. Well, it's not at all. And in fact, you can see that without even measuring it. You can see that the bushing has shifted substantially from being concentric, and well, let's see, we have finally stabilized back to, as far as the 0 point, so it's shifted about 57 thousandths from being concentric after just 6 cycles.
The conclusion of the deformation test is that the elephant racing bushing stabilized on the very first cycle. It had a total deflection of only 24 thousandths of an inch and deformation of only 2.5 thousandths of an inch. On the other hand, brand X had substantial deformation. It took us 6 cycles to get it to stabilize, and it stabilized at 57 thousandths of an inch of deformation and about 25 thousandths of deflection. This is plenty to make an oversized torsion bar rub even at initial installation. We're left to speculate how long it will take a stock torsion bar to begin rubbing.
For our next test, we are going to do an angular rotation test. Yes, I'm going to do the Elephant Racing OEM spec bushing, and from here you can read the angular position of the arm. It's starting at 72 degrees. I'm going to exercise it through 19 degrees of rotation, which would correspond to a full suspension compression or full suspension droop. That would get us to 53 degrees. 56, 55, 54, 53, there we go, 53 degrees. And we see that it snaps back very quickly. It approaches the starting position. And now we're going to repeat the rotation test with the brand X bushing. We're starting at about 72.4 degrees. We will move it through 19 degrees of rotation, so about 53 degrees is our target. There we go. You see it's only bounced back to
61 and change, almost 62. All right, that would imply that the bushing has slipped about 10 degrees. So we can actually hear the rubber. Let's hear it. That's the rubber slipping on the mount. Let's take a look at our marks. Sure enough, it's rotating easily. Just doing that with my hand.